Today we're going to be talking about how to pick structural stormwater BMPs on industrial sites. Quick reminder, Mapistry, we're stormwater permit compliance for internet age. And the way we do that is we bring in three things. One is training like this webinar. We also do a lot of in-person training with staff, and staff being stormwater team staff or production staff, just getting the basics of general awareness training in so that they're helping the stormwater team with all the stuff that's going on. The other big part is our software, which I'm going to show you how that works with BMP selection a little bit later today. But it's a complete platform to track your permit compliance, site maps, design BMPs, et cetera. It's all in one place. And then the last piece, and this is really where is when you've got problems, when you're dealing with benchmark exceedance, limits exceedances, when you need to think about in California, level 1, level 2, in Washington State, level 3 technical reports, is designing treatment systems. How do you think about that? What are the best ones out there? What's really going to work? What are you going to get your most bang for your buck? So the final kind of DIY approach I'm going to show you, and there's tons of proprietary technologies out there for this, but is downspout filters. And if you're dealing with zinc issues, galvanized roofs, dealing with zinc coming off your roof, this is a really powerful option. And also, if you're just dealing with metal issues on your sites, these work extremely well too. It's very similar to that DIY treatment system that I talked about earlier. For sediment, what you can do is take a 55-gallon drum, one of the 325-gallon chemical totes, and you just need a simple inlet pipe coming in from the left. The 90 on it is to prevent scour. So if you were to aim that straight down and extend the pipe down a little bit, it would suspend all those sediments that have settled out in the bottom of the tank or 55-gallon drum. The outlet up top has a T on it because you want to capture any kind of oils and grease or trash that might be sitting on the water surface before it goes out. So a very simple sediment, oil and grease remover. This is the DIY version of that separator that you saw before. The other thing is you can fill these with all sorts of media types. My personal favorite is like a 50-50 blend of zeolites and activated carbon, but there's a whole series that you can build in, and that kind of treatment train concept you can build in with media inside these filters as different layers. So coming in, one of the things you can do is take a 55-gallon drum, cut the top off, take a chemical tote, same thing, cut the top off. The inlet comes down. The splash rocks are just to distribute flow so you don't get any like short circuiting or bypass or channeling out when a big flow comes in. Filter fabric helps keep that separate because you need to do maintenance on the top. So any kind of sediment or debris, you want to clean that out. So the filter fabric helps not only separate the layers for maintenance, but also do a little bit more physical filtration. And then that media section can be anything from just sand if you're dealing with TSS, or to that 50-50 blend of activated carbon and zeolites if you're dealing with, say, metals issues. And then it'll flow out through another sand layer as just a final polishing step into the gravel. And then in a perforated pipe, you can just take a drill and drill into like 2-inch PVC. You can buy perforated pipe and then an outlet. Usually I like a valve on the outlet. That way I can control the flow. Bunch of different configurations out there, but this is the simplest for a downspout filter. You know, a few $100s, you can build this whole system, maybe even less if you're building lots of them. You can get that price per unit down. This can handle flow rates of anywhere from 25 to 100 GPM, depending on what the media is and how big your vessel is. Port of Vancouver also has built some of these. There's a bunch of different like formulas. Everybody's got their own recipe. This is called the Gradix, developed by two people at the Port of Vancouver. They put plants in it, a little bit of bioretention mix, and then sand. This targets metals, but you're not seeing that kind of zeolite activated carbon specialty media in here. They're really using a bioretention to remove it. So you can put plants in these. They make great planters. Put them under a building downspout. They're highly, highly effective at removing all sorts of pollutants. If you've got any of these on your site, 325-gallon totes, these work great for it. You can stack them in this configuration, and the top one can be that sediment removal separator, and then it flows over the top and into the top of the next one below it for that kind of secondary step in the treatment train and really polishing and removing metals. So you can take two of these, put them under a downspout that's got a lot of sediment, maybe, and metals issues, and have a highly functioning treatment train that you can build yourselves. Very robust, very effective at removing stormwater pollutants. The other thing is if you're doing this, you can buy a lot of these media types in something called super sacks. I believe this couple thousand pounds of media. You can lift it up with a forklift. It's got a little funnel at the bottom. Bulk suppliers will sell you this. It's very easy if you've got forklifts or trucks on site to go and fill all your units, take stuff out, etc. So you can do a lot of this yourself, especially if you have the labor and the equipment to build and design these BMPs yourself. I want to take a quick pause and go over to some BMP sizing, how to think about sizing a BMP. And what I'm going to do is I'm going to actually switch over to the Mapistry platform to show you how to do this. So what you're seeing is our main dashboard. I've got a couple demo sites in here. I'm in my Los Angeles site. And what I can see is that my average is trending over. So one, it's giving me a warning that I'm trending over for TSS. The other thing I can see as I look at my corrective actions, these are from my monthly inspections, you can see I'm having some sweeping issues and cleaning out catch basins with it not getting done, right? 26 days overdue. From a TSS issue, I can even look at my inspection records in here and I can go down. Kurt, who you'll hear from later, obviously has not cleaned out his catch basins, but you can see the sediment accumulating in that catch basin. So this is causing some concerns for my site, but what I want to show is this is kind of the lead in to actually sizing it. But these are some indicators and some data points when I'm designing a system that, hey, it's not only a structural BMP, but I need to do a better job on maintenance. And I'm pulling that from my actual inspection forms. So I'm going to switch over to the maps for this location. And what I'm seeing here is my site, and you can see a couple of drainage areas. So all my site layers are on the left. This is my site here. I've got a couple drainage areas. I'm looking at drainage area 1 and drainage area 2. That storm drain I was talking about earlier is that blue dot right here. And what I'm really focused on is this drainage area 2. And one of the things, if I click on it, I can get the square footage. So a little over 40,000 square feet. So it's a little under an acre. Now, using design storm standards that we talked about in California, this is about 90, 1 acre is about 90 gallons per minute for a treatment system. So back of the envelope, it's about 90 gallons, is a little less. So maybe we're talking more in the 85 gallons per minute. One of the things I can do here, so that's my whole drainage area and something to think about. I'm going to turn off the drainage areas. This production area, if I don't have any industrial pollutants going onto my roof, that could be considered a non-industrial area. So if I click on that building footprint, oops, that's the whole thing. Turn off another layer. But if I go to my production area, I can get the square footage of about 10,000 square feet. So remember, the drainage area is 40,000. This is 10,000. So the difference is about 30,000 square feet. So I can reduce potentially my design flow rates by 25% here. So one of the things is, remember, the drainage area is 40,000. This building, if we're not having industrial activities on the roof, we could potentially divert it elsewhere, which is giving us, and I'll turn back on the drainage area, this drainage area 2 here, minus this production area building, is about 30,000 square feet. So when I'm putting in a treatment system or thinking about it, if I need to put it in for TSS at this outfall 2 here, I would design around that 30,000 square feet. And then instead of 90 gallons per minute that we're talking initially, it might be only in the 60 gallon per minute range that I need to design a treatment system for TSS. So a couple things to think about when you're picking and sizing different flow rates and treatment systems is to leverage mapping tools in terms of figuring out your drainage area size. The other thing to think about when you're picking this treatment system is, what other BMPs am I going to implement? Am I going to do catch basin cleaning? Am I going to do stormwater line cleaning? Is it something where I want to understand how many linear feet of storm drains I've got here that I need to actually clean out? I can pull that kind of information from here. There's a bunch of things that we can look at in terms of the site map that might play into the structural BMPs I'm implementing. So I'm going to turn off site boundary and then go in and look at maybe my lines themselves, how many catch basins I have, and use that for cleaning out those kind of non-structural BMPs before I even get into the structural BMPs. So we're going to switch back over here to our BMP. So that was a quick way to do BMP sizing, pulling it from the Mapistry map and kind of understanding upstream how the inspection records, sampling data might play into that. There's both our emails there if you want to shoot us an email with any kind of questions. But one of the questions that's already come in is around DIY BMPs. You know, California's got design storm standards. Do you need a PE to certify a DIY unit? And the answer is maybe. It depends. If your site has already done had a PE do flow calculations, so like that drainage area 2 I was showing you before, if they've already done those drainage calcs and given you their sign off on them saying you need to design a BMP that can handle 65 gallons per minute, and then you go and build a BMP, you can always check that it meets those requirements. What you're required to do is to really meet those 65 gallon per minute requirements. So one way to do that would be to do a flow test with just clear water running through the system if you're doing like filtration media. So if you're worried about TSS removal, you could do a flow test in your system. Your media may allow 100 gallons per minute through it. So you've built your own BMP that can handle a flow rate that the PE designed. So it doesn't necessarily have to be that a PE goes in, looks at the device, and certifies that specific device. If you can show that a PE certified the flow calcs and your device that you picked actually meet those flow calcs. The same works if you're buying a proprietary system. If you're buying a proprietary system, you know, you need to, somebody's got to certify that the flow rates on your site are going to work for that BMP. So you need to know what your flow rate is from your site and then go pick a BMP accordingly.